Imagine blasting off into space at mind-blowing speed. Light's incredible velocity lets you zoom around our planet over 7.5 times in just 1 second. But here's where things get really trippy. Time would appear to slow down for you while the rest of the universe keeps moving normally. And as you travel faster than a speeding photon, everything around you would become a surreal blur. It's all due to photons seemingly popping into view ahead of your line of sight. But hold up, let's explore this phenomenon before we take it to cosmic speeds. Let's kickstart our cosmic adventure by understanding what makes light so fast and special. Light isn't actually a wave or a particle, it's both. It falls under the electromagnetic spectrum, which is like a long, amazing list of different types of waves, from radio waves to gamma rays. The part we can see with our eyes is called visible light. So, what makes up this incredible force? Enter the tiny building blocks of light, photons. These subatomic superheroes are the fundamental particles that make everything shine, photons. These incredible particles that defy our reality. Since they have zero mass, photons can zoom through space without any resistance or friction, making them way faster than us mortals. And fun fact, the word photon is Greek for light, a nod to their vital role in illuminating our world. Einstein brought photons into the spotlight in 1905 when he explained how light behaves during the photoelectric effect. It's like a tiny, energy-packed bullet that can knock electrons loose. Before Einstein's groundbreaking work, Max Planck had already paved the way with his hypothesis on heat radiation being released and absorbed in little packets called quanta. Since photons are bosons, they travel at the speed of light, which is mind-bogglingly fast. And as an added bonus, photons also don't carry any electric charge. They're like the invisible messengers of the universe. Let's dive into one wild thought experiment. Imagine you could move at the incredible speed of light and try to catch a photon. Sounds like a thrilling chase, right? But hold on, as photons don't have mass, they can't be caught, no matter how fast you're going. It's like trying to catch a shadow. Even if you match its pace, it stays one step ahead because it's not an object with physical presence. This is where the mind-blowing nature of light really hits home. The photons are beyond our grasp, existing solely to travel at that uncatchable speed and bring us the world around us in dazzling ways. Let's revisit our thought experiment. Imagine Billy is light, the shortest and fastest of them all, crossing the finish line first. Or rather, not really finishing since he moves at the speed of light and doesn't stop. Ben and Bob start with him a minute later, but because they travel at that same incredible speed, they're right there alongside him. Now, if Ben decides to give it an extra boost, just like in our race scenario, he'll eventually overtake Billy and reach what we can call the endpoint first, even though light doesn't really have a destination. So, in this wild chase of trying to catch up with photons, speed isn't everything, it's the added push that makes all the difference. Let's dive deeper into our thought experiment. Can you imagine trying to chase down a beam of light with something that moves faster than its incredible velocity? Sounds like a wild chase, doesn't it? The question is, can you ever catch up with light if you have an edge over its speed? Well, the short answer is yes, but there's a huge catch. Albert Einstein shattered our dreams with his groundbreaking law of relativity, telling us that nothing in this universe can move faster than the speed of light. And here comes another jaw-dropping fact. It would take infinite energy to even match the speed of light, let alone surpass it. That's right, we haven't yet cracked the code of harnessing such enormous power, so for now, chasing down light at speeds beyond its own is purely a theoretical fantasy. You're right, scientists are still exploring ways to push our understanding of physics further. Let's dive into some more mind-bending implications. As an object gets closer to the speed of light, its mass grows exponentially. Think of it like a runaway snowball effect. And this isn't just a minor change. We're talking about a scenario where the object's mass reaches infinity as it approaches the speed of light. This exponential increase in mass requires an equally mind-boggling amount of energy to keep pushing forward. The conclusion seems clear: no human, and indeed no physical object, can ever reach or surpass the speed of light. Yet, our journey into the mysteries of relativity is far from over. There's more we need to unravel before we can confidently say that nothing can move faster than light. But what if we're not bound by these same rules? Since Einstein's time, scientists have been exploring theories about particles that could potentially defy this cosmic limit. They call them tachyons, faster-than-light entities that challenge everything we thought we knew. The mind-boggling thing about tachyons is that they'd require an infinite amount of energy to even slow down and match light speed, making it seemingly impossible for any conventional object to catch up with or overtake the speed of light. Yet, these theoretical particles open doors to intriguing possibilities, forcing us to rethink our understanding of time, space, and the very fabric of reality itself. Buckle up and look up. Our search for these elusive entities begins in the vast expanse above us. Tachyons might be among the cosmic particles constantly bombarding our planet from space. When they do, they'd likely produce signals eerily similar to cosmic rays. The only catch: these super speedsters would hit Earth's detectors earlier than other particles trailing behind them. Although we've yet to lay hands on a tachyon, their existence isn't entirely ruled out. Finding one could be the game changer that proves light is not the universe's ultimate speed demon after all. The Flash may be the only one to outrun light, but we just took a leap toward understanding what could surpass it. Hopefully, this journey into uncharted physics territory has left you feeling more enlightened than Barry Allen on a caffeine high. If there's anything else you'd like to dive into, or any questions that are still leaving you in a quantum state of confusion, make sure to drop them in the comments below. Before we zip off into another exciting topic, if you're also curious about some mind-blowing magic tricks that'll leave your friends thinking you've got superpowers, check out our top 10 list by clicking on the link provided on screen. Don't forget to hit that subscribe button for more edutainment, and we'll catch up in the next video.